Good day, Acute Angels. I am Teacher Nancy, your grade 8 math teacher. For this lesson, you will learn how to solve and graph linear inequalities in two variables. Let us first define systems of linear inequalities. A system of linear inequalities is a set of two or more inequalities considered simultaneously. A system of linear inequalities can be written in four forms using the inequality symbols greater than, less than, greater than or equal to, or less than or equal to, where A, B, and C are real numbers and A and B are not both zero. A solution of a system of linear inequalities is any ordered pair x, y that satisfies each linear inequality in the system. The region where the shaded areas overlap is the graphical solution to the system. If the graphs do not overlap, then the system has no solution. Ang solution sa systems of linear inequalities ay yung region na kung saan nag-overlap or nagpatong yung dalawang shaded region ng dalawang linear inequalities. At kapag hindi naman nag-overlap or nag-meet yung shaded area ng dalawang inequalities natin, ibig sabihin, walang solution yung system natin. Here are the steps in graphing systems of linear inequalities. Step 1. Graph each linear inequality in the system on the same coordinate plane. Kagaya lamang ng pag-graph natin ng system of linear equations na kung saan gumamit lamang tayo ng isang Cartesian plane para sa isang system. Remember that when we are graphing linear inequality, we have to shade the appropriate half plane. Recall that if all points on the line are included in the solution, it is a closed half plane, and the line is solid. We only use solid line when the inequality symbol is greater than or equal to or less than or equal to. On the other hand, if the points on the line are not part of the solution of the inequality, it is an open half plane, and the line is broken. And we use broken line if the inequality symbol is less than or greater than. Step 2. Find the region where the graphs overlap. In here, the region where the shaded areas overlap is the graphical solution to the system. If the graphs do not overlap, then the system has no solution. And step 3, pick a test point in the region to verify the solution. We can use any test point to check if the solution is correct. If it satisfies both the inequalities, then the solution is correct. For example, graph the system of linear inequality x plus y less than 3 and y greater than or equal to 2 over 5x plus 3. Step 1. Graph each linear inequality in the system on the same coordinate plane. For x plus y less than 3, we will use its x and y intercepts. So let x equal 0 and y equal 0. Substitute 0 for x, we have 0 plus y equals 3. The result is y equals 3. And substitute 0 for y, we have x plus 0 equals 3. The result is x equals 3. Later on, we will graph these intercepts. And for the inequality y greater than or equal to 2 over 5x plus 3, use the slope and its y-intercept since it is written in the slope-intercept form. We just have to identify the slope and the y-intercept. For this, the y-intercept is equal to 3 and the slope is equal to 2 over 5. Let us now graph the first inequality first. So we have 0, 3 for the y-intercept and 3, 0 for the x-intercept. For the boundary line of x plus y less than 3, we will use broken line since the inequality symbol is less than. Next, we will use a test point to know the shaded region or shaded area of the inequality x plus y less than 3. Since the line did not pass through the origin, we can use 0, 0 as our test point. Substitute 0, 0 in the inequality x plus y less than 3, we have 0 less than 3. The result is 0 less than 3. And 0 less than 3 is true, therefore we will shade the half plane containing the origin or the test point. Next, we will graph the second inequality of the system y is greater than or equal to 2 over 5x plus 3 using its y-intercept 3. So for this, plot the y-intercept 3 and then using the slope 2 over 5, locate the second point, then connect the 2 points using a solid line since the inequality symbol for y is greater than or equal to 2 over 5x plus 3 is greater than or equal to. Now, let's have a test point for the second graph. We have 0, 0 as our test point. Substitute 0, 0. We have 0 is greater than or equal to 2 over 5 times 0 plus 3. The result is 0 is greater than or equal to 3. And 0 is greater than or equal to 3 is false. Therefore, we will shade the half plane opposite the test point or the origin. The solution of x plus y is less than 3 is the graph with broken boundary line with yellow shade. And the solution of y is greater than or equal to 2 over 5x plus 3 is the graph with solid line with violet shade. Now the solution of x plus y is less than 3 and y is greater than or equal to 2 over 5x plus 3 is the part where the two shaded regions overlap, which is the colored red. Ibig sabihin, lahat ng points na nasa area ng may red shade ay solution ng system na x plus y is less than 3 and y is greater than or equal to 2 over 5x plus 3. Verify the solution by picking a test point, then substitute the test point into the original inequality. Let us try picking a test point with the area shaded in red. Let us pick this point with an ordered pair negative 5, 5, and then substitute it into the original inequality. We have to substitute negative 5, 5 in place of x and y respectively. We have negative 5 is less than 3. The result is 0 is less than 3 and 0 is less than 3 is true. Next, we will now substitute it into the second inequality. Y is greater than or equal to 2 over 5x plus 3. We have 5 is greater than or equal to 2 over 5 times negative 5 plus 3. We have 5 is greater than or equal to 2 over 5 times negative 5 plus 3. The result is 5 is greater than or equal to negative 2 because 2 over 5 times negative 5 is equal to negative 2, then plus 3. The result is 5 is greater than or equal to 1 and 5 is greater than 1. Therefore, it is also true for the second inequality. Therefore, the test point with negative 5, 5 is part of the solution set. And negative 5, 5 is located into the region where the two shaded areas overlap, meaning our solution is correct. Let us pick another test point, not from the solution set. Let us try picking from the area with yellow shade. We have this point with an ordered pair 0, negative 5. Then substitute it into the original inequality. We have 0 plus negative 5 is less than 3. The result is negative 5 is less than 3. That is true. And then substitute it into the second inequality. We have negative 5 is greater than or equal to 2 over 5 times 0 plus 3. The result is negative 5 is greater than or equal to 3. And negative 5 is not greater than 3. It is less than. Our test point 0, negative 5 did not satisfy the inequality y is greater than or equal to 2 over 5x plus 3, but it satisfied by the inequality x plus y is less than 3. It is true for the first inequality but falls into the second inequality. Therefore, the test point 0, negative 5 is not part of the solution set. Remember that it should satisfy both the inequality. It should be true for both inequality. Let us have another example. Graph the system of linear inequality x is greater than 2 and 3x minus 2y is greater than 6. Let us first graph each linear inequality in the system on the same coordinate plane. For the first inequality, the graph of x greater than 2 is the half plane on and to the right side of x equals 2. So here's the point where x is greater than 2 is located and we will use a broken vertical line for this inequality. since the inequality symbol is greater than. For the inequality x is greater than 2, we will shade the region to the right side because the points going to the right are all greater than 2. Next, for 3x minus 2y is greater than 6, use the x and y intercepts. Let y equal 0 and x equal 0. Remember that in solving linear inequalities, we have to change first the inequality symbol into an equal sign. We have 3x minus 2 times 0 equals 6. We have 3x minus 0 equals 6 or 3x equals 6. Then divide both sides by 3. The result is x equals 2. And for the y-intercept, we have 3 times 0 minus 2y equals 6. We have negative 2y equals 6. Then divide both sides by negative 2. The result is y equals negative 3. Therefore, for this inequality 3x minus 2y is greater than 6, the x-intercept is 2 and the y-intercept is negative 3. Then we will connect the 2 points by using a broken line. For the shaded region, we will use the test point 0, 0. Substitute it into the inequality. We have 3 times 0 minus 2 times 0 is greater than 6. The result is 0 is greater than 6. And 0 is greater than 6 is false. Therefore, we have to shade the region opposite the test point, and that is the region with yellow shade. For this system of linear inequality, x is greater than 2 and 3x minus 2y is greater than 6, the area where the two shaded regions overlap is the solution set of the system. You may try picking any test point to check if our solution is correct. That is all for this lesson, Graphing Systems of Linear Inequalities. For our next video tutorial, we will be discussing solving problems involving systems of linear inequalities. Thank you, grade 8 students, and God bless us all.